Picture a gold bar. You almost certainly can. That familiar wedge shape, wider at the base, slightly narrower at the top, with slanted sides, is one of the most recognizable objects in the world. But here is the question. Almost nobody asks, why is it that shape? Why not a cube? Why not a simple flat rectangle? A cube would be much easier to count and easier to measure at a glance. If you were designing a container for the world's most valuable metal from scratch, a cube seems like the obvious choice. The real reason the gold bar is a wedge has nothing to do with how it looks. It has to do with how gold behaves when it is molten, how it cools, and how human hands grip a smooth 12-kilogram object without dropping it. The shape of a gold bar is not decoration. It is the answer to a set of engineering problems.
Let's get into it right here on Small Things.
Not a design choice. At its core, the shape of a gold bar is not the result of aesthetic, tradition, or symbolism. It is the result of a material that is simultaneously one of the densest, softest, and the most expensive substance humans regularly handle. Gold is extraordinarily dense. A standard good delivering bar, the kind held in central bank vaults and traded on international market, weighs around 12.4 kilograms. Gold is also surprisingly soft. Unlike steel or aluminum, gold is malleable enough to scratch with a fingernail under the right conditions. Crisp edges on a gold cube would not stay crisp. Handling, stacking, and transport would gradually round and dent them. And gold is too expensive to treat carelessly. Every design decision about its shape carries consequences. A shape that causes the problem during manufacture, storage, or verification is not an aesthetic failure. It is a financial one. How the shape got fixed? It is not arrived fully formed at the shape we recognize today. For the most of human history, gold was measured, traded, and stored in the form it happened to arrive in. Nuggets, dust, ingots of varying size, coins struck from molds. There was no universal standard for what a gold bar should look like. Different mints, refineries, and treasuries made bars across to their own modes and conventions. The wedge-like trapezoidal form emerged not from a single decision, but from the accumulated practical experience of every workshop and foundry that poured molten gold into a mold and then tried to get the solidified bar back out. When you pour liquid metal into a mold with perfectly straight vertical walls, the metal shrinks slightly as it cools and solidifies. This shrinkage is a normal property of almost all metals. Can cause the cold bar to grip the interior walls of the mold under pressure. Getting it out requires force, which risks damaging both the bar and the mold. With material as valuable as gold, damaging the bar even slightly is unacceptable. The solution foundry workers discovered over centuries of experience was a slight taper. If the mold is made slightly wider at the bottom and slightly narrower at the top, the cold bar can slide free naturally. The taper means the bar is always slightly smaller than the mold opening at the point where it needs to exit. It released cleanly, consistently, and without force. The result is a trapezoid cross-section that defies the recognizable gold bar shape. The London Bullion Market Association, which sets the international standards for good delivery gold bars, formalized these practical dimensions into precise specifications. The bars traded between central banks and major financial institutions worldwide must fall within defined weight, purity, and dimensional tolerances. The wedge shape was not imposed from above as an aesthetic preference. It was codified from below, out of what actually worked in foundries across centuries. When banks began holding gold reserves at industrial scale in the 19th and 20th centuries, consistency in bar shape became commercially important. The bar that met the standard dimension could be traded, assayed, and accepted everywhere in the world without needing to be remeasured or retested. The shape became a part of a trust infrastructure of the gold market, not because anyone mandated a particular aesthetic, but because the practical form proved the most reliable. What molten metal demands. So what happened inside a gold bar mold during a casting process? And why does the shape matter at each stage? Think about it less like a manufacturing step and more like a negotiation between the metal and the constraints of physics. Molten gold is poured at a temperature of above 1000 degrees Celsius. In that stage, it flows freely, filling every contour of the mold. As it cools, several things happen simultaneously. The outer surface of the bar begins to solidify first, while the interior remains liquid for longer. This uneven cooling creates internal stresses in the bar. It also causes the surface to contract slightly as the interior follows. The result is that the bar shrinks away from the mold walls on the sides and bottom as it cools, but may press against the mold walls at certain points depending on the geometry. The taper sides of the trapezoidal mold work with this physics rather than against it. As the bar shrinks, it moves in the direction of the taper, pulling away from the wider parts of the mold. By the time the bar is fully cool, it is naturally positioned to slide out of the mold in one direction without resistance. The weight of the bar also matters during cooling and handling. At 12.4 kilograms, even small design choices have consequences. A wilder base means the bar center of mass is low when it is placed flat, making it stable during storage and stacking. A cube of equivalent weight would have its mass distributed higher relative to its base, making it slightly more prone to toppling if bumped or misaligned. The slanted sides also provide something that flat vertical faces cannot: the grip. When a vault worker in protective gloves picked up a smooth, cold 12-kilogram gold bar, the angle faces give the fingers a natural resting angle that flat sides do not offer. It is a small detail, but when the object in question is worth several $100,000, a grip that is 1% more secure matters. It is not about looking expensive. The assumption most people carry about the gold bar shape is that it is purely symbolic, a choice made to make gold look prestigious, important, and different from ordinary objects. That assumption misses the practical logic entirely. Every feature of the gold bar shape exists for a functional reason, not an aesthetic one. The taper releases from the mold. The wider base provides stability in stacks. The slanted sides assist with grip. Even the top surface of a gold bar, which is slightly recessed and uneven compared to a perfect flat face, serve a specific purpose. It provides a stable area for the stamps and markings that allow the bar to be identified and verified. Each gold bar carries pressed or engraved markings identifying the refinery, the weight, the purity level, which is typically 99.99%, and a unique serial number. These markings are not decoration. They are the primary verification system. A bar that cannot be clearly identified cannot be reliably traded. The shape of the top surface, which is slightly flatter and more contained than it would be on a cube, provides a consistent stamping area that remains legible after handling and transport. If the shape were primarily symbolic, it would have varied more across different countries and historical periods. Instead, refineries across the world converged on the same basic trapezoidal form independently because they were all solving the same set of problems with the same material under the same physical constraints. the same shape everywhere. Today, you will find the same trapezoidal gold bar shape in the vaults of central banks in London, New York, Frankfurt, Tokyo, and Beijing. The Bank of England alone holds around 400,000 gold bars. Each one conforms to the good delivery standard, between 350 and 430 troy ounces in weight, minimum 99.5% purity, and the characteristic tapered form that allowed it to be stacked, handled, and identified consistently. Every bar in that vault was produced by a different refinery in a different country, yet they're all interchangeable because they all meet the same physical specification. The consistency is not a coincidence. It is the infrastructure of trust that makes the gold market function. A buyer in Tokyo accepting a gold bar that was produced in Johannesburg and shipped through London needs to know, without inspecting the mold or watching the casting process, that the bar is what it claims to be. Smaller gold bars, the kind sold to retail investors and collectors in 1 ounce or 10-gram sizes, often come in a different form. Flat rectangles, produced by a different manufacturing method called minting, where a machine presses gold into precise shape under high pressure. These smaller bars cannot cast from liquid gold, so the mold release problem does not apply. But the large cast bars, the ones that move between central banks and underpin the global gold market, remain trapezoids for exactly the reason they always have been. Practical engineering in plain sight. So, why is a gold bar not a cube? Because a cube would be harder to remove from the mold, less stable to stack, and more difficult to grip. The wedge shape solves 4 separate engineering problems with a single form. It releases from the mold without force. It sits stably with its wide face down. Its angled surfaces give human hands a reliable grip on a smooth, cold, 12 kilograms object, and its top surface provides a consistent area for the identification marking that allows it to be traded globally. A gold bar may look like a symbol of wealth, but its shape is a practical solution shaped by heat, weight, and the demands of moving something irreplaceable safety through the world. It is not designed to look rich. It is designed to work. If this video changed the way you think about something you have seen 1,000 times without questioning it, let us know in the comments what everyday object you want us to look at next. We might make it in our next episode. Thanks for watching. History often hides the smallest details.